Alright, chapter 5.3, again we skipped over 5.2. There's some things in here that I guess you could say are important, but they're not absolutely important. So I don't like to waste your time, especially with us going through this quarantine thing. There's no need in over teaching anything, but I do want to make sure you're exposed to as much as you need to be exposed to so that next year you'll be ready when you get into geometry. See, the bad news is, yes, we are learning from home, and yes, we can complain about how much work I'm giving you, but the geometry book does not change simply because we're in a quarantine period. So there's still things you need to know. And so I'm doing my best to make sure that I still put those things in front of you and at least get you experience with them so that next year you'll be ready for it. Otherwise, when you get to geometry, it's going to be really tough. Plus, and sorry I'm talking so much, but here's a good strategy you need to consider. If you are learning the material this year, but the majority of people aren't learning the material, then that means you're going to be ahead of a lot of students, and typically the teacher slows down for those students, which means that you're putting yourself into a good spot to have a pretty easy geometry course or whatever it might be that you're doing next. So other than that, today's lesson is full of processes. They are not difficult processes, but you have to put some time in if you want to execute them properly. For example, we need to be able to graph a line from an equation. We need to be able to write a line passing through, or write the equation of a line passing through 2 points, and we need to interpret an equation and its values. So as stated earlier, none of these are extremely difficult. Let's just go ahead and get to it. So graphing a line in slope-intercept form. Remember the slope-intercept formula, and we've seen it already, is y equals mx plus b. We know that m represents slope. That we've learned from our chapter 4. That's why I like chapter 4. But now you have to understand that b represents your y-intercept, or what you call your initial value. In general, it's the starting point of the graph. You will always, whenever you're graphing a line, start from b. This is where you go first, this is where you go second. And it's very important that you know that. So again, write down whatever you need to write for that, but that's what you need to have in your mind. So when we go to graph this part here, again, we know that m is 2/3. We know that b is -4. You will start with -4 by going down 1, 2, 3, 4. And if you remember that m is rise over run, from here we rise 2, which means up 2, and go over 3. That's our 2 points. We draw our line through those 2 points, or your computer will draw that line for you, but that's pretty much all that's necessary. But again, the key thing is b is first, so go to that number first and then use that number for your slope, and that's that. If you were asked to graph this, again, first we want to understand that m is -3/2 and that b is 1. So the first thing we do is we look at b, which tells us to go up 1, and then from there, -3/2 means, remember, go down 3 and always run right. So right 2, and we draw our line through those 2. But that is how you graph a line in slope-intercept form. The last one, of course, has this number here where m is 5, b is -3, but we need this to be a fraction. Anytime you want to turn your whole number into a fraction, simply put that number over 1. But again, we start with b, go down 3, and then this is 5 over 1, so 1, 2, 3, 4, 5 over 1, and once again draw the line that goes through those 2 points. That is really simple to do. It's going to take practice, but again, once you get it down, again, it's not so hard to do. Just make sure you get this process down, because the next lesson is going to show a different type of equation and how to graph that, and you'd want to have your first equation under control before you start trying to learn a second one. Another one that we have is pretty much one example. It's a problem from chapter 4, so you just have to adjust your perspective for chapter 5, and that is where you have to write the equation of a line passing through 2 points. Now, when you see write the equation of a line, you're going to remember that it's y equals mx plus b. The thing is, we have a y, we have an x, but we do not have an m. And so what I would do is find m first. And the way I like to find m is by putting my numbers into a table and doing my subtraction the way I learned here, which is -9 over 3 or -3. So my m is -3, and I'm going to choose one of those points. That means my y is 1, my m is -3, my x is 2. Work out your problem here. Move the 6 by using its opposite. There's your m, there's your b, and your final answer is y equals -3x plus 7. Again, it should work both ways. If I plug in 3 times negative, or negative 3 times 5, that's negative 15 plus 7, which is about negative 8. So we know that it does work. Again, I'm not going to do a bunch of those because we did a lot of those in chapter 4. And if you have an issue, again, just feel free to send me a picture of what you're doing on paper, and I should be able to help you figure out what to do to get to your answer. Last thing we're going to do is interpret an equation. Again, you must apply your understanding of rate of change and slope and the initial value, and once you get through that, everything else pretty much takes care of itself. Now, this is not a question that you have to worry about because we are learning remotely, but it is an important question for you to be able to do. If it said the equation 6 plus 0.75x represents the cost y for a trip to the state fair, where x represents number of ride tickets purchased, and they want rate of change, remember that rate of change is slope. Remember that slope is attached to x. In this case, 6 is not my rate of change. 0.75 would be, because all we did was switch our m and our b around. Your initial value is your b, which means that that will be your 6. The real question is, what does 0.75 represent in terms of the situation? Well, 0.75 is money, so it's 75 cents times x. Well, what's x? Number of ride tickets, so it'll be $0.75 per ticket would be what it would represent. And then it's going to ask you, or would ask you, something like, what does 6 represent in terms of the state fair visit? Well, again, if that's what you pay one time, if you think about going to the fair, that is more unlikely your entry fee. In other words, you paid $6 to get into the fair, and you paid 75 cents per ride. But again, you don't have to worry so much about that question because, again, it's not really something that's going to pop up with us learning remotely. I just wanted to make sure I put it in front of you. There are other types of problems on your homework, but you have experience enough to work your way through them. Just email me, let me know. Again, be ready to think. Once you get it, the material is easy to do. Continue to work hard so you can stay on top of the information, and you will have a good amount of time to review and practice after today, but you are still responsible for the fundamental ideas that have been presented. Next week is Thanksgiving break. There is one topic to talk about, and your test is on Wednesday. Now, I need you to think about this, because your test will be made available Wednesday, but then you have Thursday, Friday, because those days are off, Saturday as usual, Sunday as usual, and Monday before it has to be done. So even though this is your test day, you have 1, 2, 3, 4, 5 extra days to actually get it done. So hopefully you give yourself a decent setup to where you're ready for that. But again, that's on you. I have done my job, or done my best, to make sure that you have the best opportunity to succeed. But if you're not trying to get yourself into a good position, I can't do anything else. So here are the notes. Make sure you answer the question at the end of the video, and that's about it. Good luck.